Hello friends, very good evening to all of you. Today let us discuss the question number 19 under OOPS ABAP question answer series. The question is what is Dialog step, database LUW and SAP LUW. This is most commonly asked question among SAP architect level developer. So let us understand dialog step. What is the dialog step? And smallest unit of work performed by SAP system with respect to a screen or DINPRO in an SAP system is called dialog step. So dialog step I have depicted here in a diagram. Let us see in this diagram. This is the user which is having a screen 1000. On screen 1000 he is supposed to enter some value, some string variable or some input he is supposed to give on this screen 1000. Once he enter all the value, then he press the enter button and he goes to the screen 2000. When he goes 2000 from screen 1000, the system must have to process the PAI logic and PBO logic. So the in between steps covered between screen 1000 and screen 2000, that is known as a single dialog step. So in our scenario, this is a first dialog step. So when a user gives some input and press some function button or some submit button or some save button or whatever activity, and when he goes to the screen 2000, so in between a step performed by SAP system is known as a single dialog step. The in between step between two screen is known as single dialog step. It consists PAI and PBO. Similarly, when user comes to the screen 2000, again he has to give some input here and perform some function code to execute whatever he has given, so that it can update in database and he can go to the final screen 3000. Okay, so again this step is also known as a dialog step. Between screen 2000 and screen 3000, whatever the process, whatever the step followed by the SAP system, that is known as a dialog step. Here same, when the user comes to screen 3000, then this is his final screen where he has to again put some data and press on the save button. So once he presses the save button, again he comes to the same screen, and on the status bar he is able to see the message successfully saved. So here also this is one some sets of process has been there in terms of PAI and PBO. In terms of PA and PBO. So this is also a single dialog step. So here we can see there are three dialog steps. First dialog steps, and this is the second dialog steps, and this is the third dialog steps. Now let us so now let us understand about database LUW. See, database LUW, as we know the property of database. So what is the property of database? We all know property of database is ACID property. Any database system must have to follow this ACID property. ACID, A stands for atomicity, and C stands for consistency, I stands for integrity, and D stands for durability. So this is the property must be followed by a database system. So here when the picture comes of database LUW, this is database LUW is also known as database transaction. Database transaction is nothing but some set of process performed by a database to update the data underlying the tables. So this is the database LUW, means database transaction, which consists some set of processes to perform the operation. So here we are most concerned about this atomicity property. atomicity property. So DBLUW is responsible for atomicity. DBLUW is responsible for atomicity. So just let me mark it. Okay, this is a bold color because this is our most concerned. So atomicity. So atomicity, this atomicity is taken care by database LUW. So when a dialog step is performed, it is assigned to a work process. That work process is a dialog work process. Single dialog step is assigned to the single dialog process, dialog work process, and that work process opens a database LUW if some database operation is involved in the statement, like it can be modify, it can be insert, it can be update, whatever the database statement, if it is written here in PAI or PBO, that triggers the DBLUW. So this DBLUW maintains the property, this atomicity property. Atomicity property, let us understand about atomicity property. What is this atomicity property? Atomicity property means either all or none. Either all or none. All means if one transaction starts, then following transactions under DB must be completed successfully. If any one of the set, if any one transaction of uh, complete set gets failed, then all the transaction must be failed. All the transaction must be failed. Better to say all the process must be failed. If we understand like this, that one single transaction, one single DB transaction, not SAP transaction, I'm talking about DB transaction. If a single DB transaction consists multiple operations, then in that case either all the operations should be successful or a sing or all or completely it should be failed. Either it should be successful or it should be completely failed. In that way the atomicity is maintained. So for maintaining the atomicity, our DBLUW is the most responsible agent, most responsible things, or most responsible fact in the SAP system is there. Now similarly, when you come from a screen 1000, from a screen 1000 to a screen 2000, what happens, that there happens one implicit commit. When you come to a screen 1000 from a screen sorry, when you come to a screen 2000 from a screen 1000, then without, if you are not writing any commit work statement in PBO or PAI, then also work process, the dialog work process itself does the implicit commit before coming to this screen 2000. Okay, so this is one very most important thing. This will, I will show in an example uh, in this video only later. So now when you come to a screen 2000 again, and you are and again you reaches to a screen 3000, then there also by this dialog steps is assigned to a work process, and that dialog work process creates one DBLUW which communicates with the database and responsible for atomicity, either all or none, either all or none. Similarly here also the scenario is there. Now what is SAP LUW? See, when we talk about SAP transaction, then there multiple DB transactions are involved. when we talk about a SAP transaction. Suppose we take MM01 transaction. In that there comes multiple screens, multiple dialogues, and user has to perform many inputs, and at last he has to click on save button or some function code related input he has to give. So in that case what he has to do, that once he performs the action, so the final input, before coming the final input, there happens multiple database LUW. There happens multiple database LUW. See here, you can see in this example there are three database LUW, and all the database LUW must be consistent together. If there is any dependency, then all these must be together, logically related, and it should be in such a way that so that it should be consistent. Okay, but the thing is that when you come from a screen 1000 to a screen 2000, there automatically happens the implicit commit. Then how this can be achieved? So that is the second part, how we can achieve. But let us first understand in a very good way, that what is SAP LUW. So SAP LUW is nothing but it maintains the atomicity under SAP, for a SAP transaction. It maintains the atomicity for a complete SAP transaction where multiple database LUWs are involved. That means if a transaction is getting there, if a transaction is happening there, or if a transaction is occurring there, then it should be completed either successfully or nothing at all, or completely not. It should be either completed successfully or not at all, so that the integrity of database can be maintained in a nice way. So this is the work of SAP LUW. Hope it's clear for you. Now let us come how we can achieve the SAP LUW when the implicit commit automatic triggered by work process when we come from a screen 1000 to a screen 2000. So there are some ways given by SAP. One way is update function module. With the help of update function module, what we can do under PAI or PBO, whenever we require any database update, we can modularize the code in a function module, and we can call that function module in update work process. Okay, so similarly for this also, if there, suppose if there is some dependency over here on this, so the first this should be completed, this process should be completed, then this process this database related here, whatever you have written the code, if that code is related with a database operation, and that is dependent on this, then this code also you have to write in update function module. And similarly, if there is also some dependency on database level, then you have to again write some another function module in a update as a update function module. And once at last when you write the commit work, then in all the update function module stores in a VBLog table. There is a table called VBLog. There you can see the that those update function module contents will be there, and they all gets executed in a sequence. They all gets executed in a sequence once the commit work uh, is executed by the control. Then all the code all the operation written in the update function module gets triggered sequentially, and by this way the SAP LUW can be achieved. There is also one another whereby which you can one way is call function module in update task. This is also known as update function module. Update function module, this is also good interview question. Update function module, interviewer can ask what is update function module. So I will also prepare one video on this update function module, and I will I will uh, keep it, I will post on YouTube. And there is one another technique is here, perform form name. You have to write a subroutine here, and on commit, perform routine, and all the things, all the related database operation code you have to uh, means you have to write in this form name. But uh, this is there are different ways where you can implement all these things. So I will prepare a video in which I will describe it about update function module, this perform, this form name, and on commit. And there is one way also that on RFC destination, suppose you have a RFC system where you want to perform all these database operation asynchronously. So by a TRFC, that means via background task, we can also achieve this thing. So via background, calling the function module in background task, and this also works same as the update function module. Like uh, uh, counter the commit work statement, then it starts updating the database related all the code. So by three way we can achieve the SAP LUW. SAP LUW can be achieved by three way. One is call function in update task, that is update function module. Another is perform subroutine on commit, and third one is via call the function module in background task, that is TRFC. You can also call it as a TRFC. I will come in another video with a detail for update function module, this perform subroutine, and the this call function module in background. Okay, fine. Now I would like to see, I told that I have prepared one program where I will show you the implicit commit, how the implicit commit work. So see, I'm having right now one table. This table is completely empty as of now. We can see number of records is 0. If we execute, we will not get anything because no table entry is found for this. There is no table right now. Now let me put one entry in this. So first I will show you about the program. This is the program I have written. Parameter I have declared. This parameter is a radio button. One is for adding the entry, so I have named it as a p underscore add, and one is for deleting the entry from the database. Now I have declared the parameters for getting the input. Okay, one parameter is for employee ID, uh, another is for employee name, and another is for employee age. So these are the three parameters. We have to get all these parameters in a structure, and from that structure, from that work area, I have prepared this work area ls table, and from this work area we are going to update, we are going to create the record in this table. Okay, and suppose if we want to delete the record, then we can delete the record as well. See, before this I have not written any commit work. I have not written any commit work. You can see there is no commit work code written here. Okay, so let me save it, activate it, and you can see here there is no commit work. But still, if we get see, this is our screen, and we are going to put some entry. Let us put one. I'm writing my name here, Pankaj, uh, and age 31. Okay, so and let me execute it. I have executed, it has been executed successfully. There is no commit work statement, but because this is a dialog step completed, once a dialog step is completed, implicit commit automatically gets triggered by work process, dialog work process. Okay, and it insert the record in the database. We can see the entry in the database. One record is here. Let us see the content of the database table. Content of the database table, you can see here. I have entered employee ID 1, name Pankaj, and age 31. Similarly, you can do multiple experiment with uh, such kind of program. I have not written at all anywhere commit work, but we are able to see that data is getting saved in the table. Let me delete the data. One, I'm just giving my employee ID name. No employee name is required. With the help of primary key itself, the data can be deleted. Execute it. Got executed. Let us see the entry. Number of entry is 0. I have not written any commit work statement. So in this case, what happens? Implicit commit got triggered. Implicit commit got triggered. Hope it's clear for you. Triggered. If you have any question, you can put in the comment box. If you like this video, please like and subscribe. Thank you very much for watching.